So next, let's look at adjacency matrices. So, I'm not sure if you guys have seen matrices before, but you will cover this in this topic, but also if you do methods or any other type of maths, matrices you'll cover. So matrices are just ways of representing information, similar to a graph. So a graph represents information, a matrix, just another sort of way of representing information. But matrices are actually very, very useful in mathematics. So if you haven't come across them, you will very soon. Excuse me, guys. So, we have an adjacency matrix here. So an adjacency matrix is actually a special type of matrix because it actually displays the connections of the graph in sort of matrix form. And each node in the graph has been given a letter. Okay, so basically we have rows and columns in the adjacency matrix. And the way that we sort of read the adjacency matrix is, first of all, let's look at just a random sort of number. So for example, this 1 over here. And it's at the intersection of B and C. So what that basically means is that there is one connection between the nodes B and C. So as simple as that, we are basically sort of looking at the connections and sort of generating them in the matrix. Okay. Next, we have adjacency lists. Again, very similar to an adjacency matrix. It's to represent the connections between the different nodes. So, the way that we read this is, for example, A, there is an arrow going to B, C, and D. Basically, it shows that A has connections to B, C, and D. An adjacency matrix is actually a little bit more useful because it not only shows you that there is a connection, it also shows you how many connections. So for example, for A and D, there are 2 connections. So there will actually be a number 2 at the corresponding row and column for A and D. Whereas here, we are just writing down what the actual connections are, not giving any indication on the quantity. Okay, so what are the applications of this? Like you will already know, specialist maths is all about application. It's learning about the practical skills that will actually be applied in the field of mathematics and physics. So the applications of this topic is, for example, electrical circuits, social networks, molecules, utilities. So obviously there's going to be a lot that you can do with a network. So if you do general maths by any chance, the applications within general maths are a lot different compared to the applications in specialist maths. So application is a dot point in study design. So definitely expect it to be assessed. So just like briefly what those applications could sort of constitute. For example, if we have an electrical circuit, the vertex could represent the wires in the circuit. We could have resistors, voltmeters, all that sort of stuff. So really sort of applicable stuff in real life. So social networks, really common, where we have, individual people, and we are and the lines or the edges sort of represent the accessibility of connections between different people. Molecules, where the vertices represent atoms and the lines represent bonds. Utilities, so house connections to water companies, all that sort of stuff.